Have you ever done a science experiment and wondered what it'd be like if you did it big? I have.
Yeah!
My name is Phil, and I take your everyday science experiments and do them big. This is Science Max, Experiments at Large. Science Max! It's time to get stuck on magnets. What's our attraction to magnets? What's their attraction to each other? And can I use magnets to levitate and float in the air? All on this episode of Science Max, Experiments at Large.
Greetings, Science Maximites. Welcome to Science Max, Experiments at Large. My name is Phil, and today we're going to be looking at the power of magnets. You see, magnets are fun things to experiment with because they are really, they're really interesting. This magnet that I've got here is a neodymium magnet, or a rare earth magnet. It's one of the strongest magnets you can get. A magnet is an object that is attracted to anything that is ferromagnetic, which is iron, nickel, or cobalt. And magnets are interesting because they have two sides. There are two poles. I'd show you, but I can't get the chain off. Hold on one second. Ha-ha! There are two. Oh, no. There are two poles to every magnet, just like the Earth. There is a North Pole and a South Pole. That's right, the Earth is a giant magnet. So, if you take kitchen magnets, you'll find that there's two different poles. I've written north and south on these ones. They don't normally come like that. If you put the north and the south together, they stick. But if you put the north and north or south and south together, they repel. They repel, see? They don't want to go together at all. And you can force them together if you want, but if you do, they will spring away the second you let them go. But when magnets repel each other, I find that some of the most interesting stuff. Check this out. This is just a small container, and I've got a magnet in here, and I have a loonie attached to it so that it fits nicely in the container like that. For the top, I've attached two magnets together, and I have another coin on it. And if you put them in there, I've made sure that the two poles repel each other, which means this magnet will just sit there and float. Magnetic levitation. Very interesting. And you can pop the top on that if you want and just carry around a levitating magnet. Now, there's a couple fancier ways you can levitate stuff with magnets. This is just a wooden frame I've made. This is completely not necessary. You can use just about anything in your house. A desk lamp works really well. The important part is I've tied a magnet to the end of this arm here, and this is a bolt, which is attracted to the magnet, but it's got a thread tied to it, so it can't get there. Just far enough that it will actually hang in mid-air. Look at that. It's not attached to anything. It's just being pulled up by the attraction from the magnet. The thing is, as soon as you pull the bolt away far enough, it will lose the attraction and it'll just fall. Very cool. Here's one that's a little bit more complicated, but is also really neat. This one uses disc magnets, which have a circle or a hole in the middle of them here. And you put two around a pencil and then four more in such a position that you can put the pencil against this wood on the side and it will just levitate on its own. You can even give it a spin. Look at that.
And if you want to make the levitating pencil yourself, there's step-by-step instructions on how to build an easy-peasy version on our website.
Meantime, we are gonna max this out. Magnetic levitation on Science Max Experiments at Large. But you're probably thinking, what are we going to levitate? Well, we're going to levitate meat. At least, that's the plan. That's why I'm going to the Center for Skills Development and Training. Come on.
Okay, who turned out the lights? Guys, ow, what was that? Why is this room so small? And only going down to waist level. This is the weirdest room I've ever been in. Where am I? What's going on?
Hey, Matt.
Hi, Phil.
This is Matt. He's from Jobmaster Magnets. Now, you guys use lots of big magnets, right?
That's right, we do.
Awesome. So maybe you could help me max out this.
Wow. You did a great job of building the levitating pencil experiment.
Yeah, so what's going on here exactly?
Well, all magnets have at least a north and a south pole.
Right.
And when you put like poles together, they want to repel.
Oh, okay. So have you ever levitated a person?
Not yet.
Well, let's do it.
All right.
Do you think we can use these?
We can try.
Okay, well, put that one on the ground. And, okay, so north, and I'll put the north one on my foot here. And then if I just step, oh, wait a minute. If I step, stop moving. If I step on the, okay, well, first of all, this magnet keeps sort of moving away from me when I try to push down on it. What do we do? How do we fix this?
Well, we need to keep the magnets in position so that they don't move around when you try to bring them together.
Yeah, because I have to come straight down on it, don't I?
That's right.
So why don't we attach this one to the floor?
Good idea.
And then we'll put a board on this one, and we'll see how it goes.
Perfect.
Okay, let's do it.
All right.
This is a magnet. This is a magnet. This is a magnet. This is a shoe. What's the difference? To know that, you have to know your magnets. This is a donut. It does not stick to this magnet. This is a spoon. It sticks to this magnet. These paper clips stick to this magnet. This shoe does not. So what is attracted to magnets? Only things that are ferromagnetic. Here's the difference. Horseshoe, horseshoe magnet. This one is a magnet. This one is not. But the horseshoe sticks to the horseshoe magnet because this one's a magnet and this one is ferromagnetic. Only things that are ferromagnetic are attracted to magnets. Things that are not attracted to magnets, they're not ferromagnetic. Plastic, banana, mitten, sandwich, magazine. No. But how do you know? Do you go around the world sticking a magnet to every single thing one at a time? Hey, Ma, I need you to come over. I need to see if you're ferromagnetic. No, ferromagnetic. No, you don't need to do that. First of all, only metals are ferromagnetic. So that eliminates all your clothing, your luncheon meats, your magazines, what have you. Everything that's non-metal, you don't need to worry about. Never mind, Ma, it doesn't matter. But this clock is metal. It doesn't stick. Well, not all metals are ferromagnetic. Mainly just the ones with iron, nickel, or cobalt. And there you have it. Now you know your magnets. I hit the phone on the magnet there. Can you hear me, Ma? Hang up the phone. Hang up the phone, Ma.
My first attempt at levitating had the magnets sliding all over. So the plan is to take the bottom magnet and attach it to a big wooden board so it won't go anywhere. Then attach another plank to the top magnet to make it a little easier to stand on. Okay, that is definitely attached to the floor. Thank you. All right, now, if I just get this lined up, oh, look at that. It could totally, oh, wait a minute. Totally, it doesn't want to stay put. Oh, wait a minute. They levitate. Come on, levitate. Why doesn't it want to stay? It just doesn't. Should I stand on it? Okay, I'll stand on it. Here we go. And am I levitating?
No.
No. So why isn't this working?
Well, just like your pencil experiment, We need a shaft through the center to hold the magnets in position.
Oh yeah, maybe we could use like a ring magnet.
Yes.
That like we used with the pencil.
Right.
And
And we're gonna need stronger magnets.
we're gonna need stronger magnets. Are the ring magnets strong?
Yes, they can be.
Awesome. All right, let's do it.
All right.
Now it's time for a Science Max quiz. Which one of these things do we have magnetism to thank for? Birds flying south in the winter, music, or a sandwich? If you picked A, you're right. Some birds migrate in the spring and fall using the Earth's magnetic field. Many animals can sense the Earth's magnetic field and use it to navigate. Migrating birds fly hundreds or thousands of kilometers north or south when they migrate in the spring and fall. A compass works the same way, by using magnetism to point to the Earth's magnetic North Pole. But if you picked B, music, you're right! Here's some music. The way you're hearing this music is because the musicians recorded their instruments using microphones, which use magnets. And then the signal was translated by a computer and stored on its hard drive, which uses magnets. Then it was broadcast to your TV and comes out your speakers, which use, you guessed it, magnets. And for those of you who said you have magnetism to thank for your sandwich, haha, well, you're right. You see, you'd probably go to the kitchen to make that sandwich, right? Well, I'm guessing you got all of the tasty ingredients from your refrigerator? Well, it works on electricity, which is produced by magnets. And then there's an electric motor in the fridge that circulates the air and keeps it cool. And guess what? Magnets. And finally, the door on your fridge stays closed because the door has magnets. So there you go. You can thank magnetism for birds flying south, music, and your sandwich. It just goes to show, when you're talking about magnets, everybody wins because magnets are everywhere. This has been a Science Max quiz.
Mini Max.
Here's an experiment you can do with a bag of water. Take a sharpened pencil and carefully push it through the bag. If you do it carefully, it won't spill. The reason this works is because the bag is made of polymers, long stretchy chains of molecules, and also because the pressure of the water against the pencil prevents any water from spilling out. Now, we're gonna max it out. This is a very large bag of water, and here I have some very large pencils. You ready? Oh. That's one. That's two. Here we go. Should I go from the bottom? Ta-da! Science! Okay. I know what you want. Like I was saying, science! Turns out trying to balance two repelling magnets on top of each other is pretty much impossible. Here's why. This is a magnet, and here is the magnetic field. It's often drawn with lines like this, but actually the magnetic field radiates out in all directions. Really, think of the magnetic field kind of like a ball. When you try to balance another magnet on top of the first magnet, it's about as hard as balancing one ball on top of another ball. So here's the plan. Just like the levitating pencil, we're going to use ring magnets because we can put a shaft through the center of one ring, then drop another ring magnet on the shaft. It will keep them perfectly aligned. Then it's just a matter of putting the bottom magnet on a board to keep it stable and using another board so I can stand on it, and ta-da! Magnetic levitation! Or at least that's the plan.
Okay. Board,
Magnets.
magnets, Ooh, look at that. Awesome. And now I'm gonna put the platform on. Nice. I got some weights here. Let's see how this works. Yeah, this is gonna work amazing. All right, think I should try it?
Give it a try.
Okay. Here we go. Yeah! I'm doing it! I'm levitating! What?
Just a little bit.
Oh, really?
Yeah.
So, yeah, what do we do?
We need more power.
More power? I like that idea. How do we give it more power?
More shafts, more magnets.
Okay, sure. Well, why don't we do 1, 2, 3, 4 shafts, and then we'll have magnets on all the shafts.
Great idea.
All right. Let's do it. If you attach something ferromagnetic like this washer to a magnet, not only does it stick, but the magnetic field travels down the metal, making it a magnet too, which means you can stick more and more things to each other, and they will continue to stick until you run out of magnetic field. You can do this yourself at home with anything ferromagnetic. Paper clips work pretty well, or washers like I have, or screws or bolts, and they'll continue to stick to each other as long as the magnetic field is strong enough. You can see it's getting pretty weak here, and they'll all stay magnetized as long as the first one is still attached to the magnet. But if you want to go even further, all you need to do is keep adding more magnets to reinforce the magnetic field. I've got a few here, like this. Let's get the chain started, like that. And then I've got a magnet attached to this washer, so it will keep the magnetic field strong. And I continue to add one magnet, one washer, and we'll just see how far I can go. You can even sculpt it a little bit. Look at that. And then at the end, a whole bunch of paper clips. Eventually, the weight will make it fall off, but it's a lot of fun to play with magnets and make art. Speaking of art you can make with magnets, you can also make sculptures. When everything sticks to everything else, you can make some pretty fancy designs. This is a rare earth magnet, a very strong one, and a bunch of nuts that I've gotten. And this one here is an electromagnet, but electromagnets are a little different because they need an electric current to work. Check this out. This is sort of a magnet dude with crazy hair. There's an earth magnet here, and this is a giant screw, and these are some metal bits, and then I've got 2 more magnets at the top here to hold on his crazy wire hair. He's got crazy wire hair because he's crazy magnet dude. Now, of course, we couldn't just talk about magnetic sculptures without maxing it out, so let's max it out. This is a bunch of scrap metal from leftover experiments, and I've got a bunch of rare earth magnets, and now I'm gonna max out a magnet sculpture. Let's see. There you go, a maxed out magnet, me! I made this guy out of metal pipes with earth magnets in between, and these are his arms attached, of course, with magnets. His hand, his little metal pieces attached with magnet. Steel wool for the hair, and of course, hat, non-magnetic. All right, here we go, ready? Want to see a magic trick? Simple copper tube. Drop things through it. Nothing unusual happens, but watch when I drop a magnet through. What? It's not magic, it's science. Because the magnet creates a magnetic field, when it goes through the tube, the magnetic field repels the magnet upwards. Now, the field isn't perfect, so the magnet doesn't come to a stop, but still, it slows down from a fall to a nice, graceful drop. Take a look from above. Pretty amazing, right? Magnets, not magic, science.
so I've managed to levitate on some magnets, but just barely. What Matt and I needed was more power. So instead of having one shaft and one pair of ring magnets, we're going to use a larger board and put a shaft on each corner. Then we'll have 4 times the power because we're using 4 times the magnets. Hopefully this will be strong enough to get me floating on a cushion of magnetic energy.
And magnets?
Magnets.
Okay, here we go. This is gonna work great. And top board. Ooh, what do you think?
Looks great.
Yeah. Okay, here we go. Matt?
You're levitating.
I'm levitating! Woohoo! All right. It feels cool. It sort of feels like surfing a little bit. All right, thank you so much, Matt. That was amazing. And there you have it. Science Max, Experiments at Large, Magnetic Levitation. You know, I'm surprised we could do an entire episode on magnets, and we never actually got them so close to the camera that the camera went all weird, because cameras and magnets, they don't, oh dear, no, that's okay. I can fix this. If I just maybe, no. Maybe if I put the magnet to the camera again, that would, okay, that's not, that didn't help. Oh, okay, well, thanks very much for watching Science Max, Experiments at Large, and we'll see you again as soon as we...
Have you ever done a science experiment and wondered what it'd be like if you did it big? I have.
Yeah!
My name is Phil, and I take your everyday science experiments and do them big. This is Science Max, Experiments at Large. Science Max! This episode of Science Max is all about liquids. What makes something float, or not float?
Oh no! My loonies!
Liquid density and super absorbent gel.
Who wants to do an experiment with diapers?
Liquids. Today on Science Max, Experiments at Large.
Hey, welcome to Science Max, Experiments at Large. I'm Phil McCordick, and hold on a second, I'm just gonna change. Okay, that's better. Now, where were we? Oh, right. Let's go make a boat. So you know that some things float and some things sink, like rocks, or wood, or full water bottles and empty water bottles, or carrots, foam, waffles, screwdriver, playing cards, plasticine, tinfoil, potato, my watch. Wait, that wasn't supposed to go in there. So how do you make a boat? You make it out of something that floats, right? Well, most boats are actually made out of metal. Tinfoil is metal and, well, it sinks. But if you fold tinfoil into a boat shape, it floats. And boats don't only float themselves, but they can hold people and cargo. In fact, there's container ships crossing the ocean at this very moment that are holding thousands of tons of cargo, and they're all made of metal, which doesn't float, it sinks. So how do boats do it? Are they magic? No, of course not. Boats are science. And here, you can be science maximites. Get some tinfoil and cut it into the same size pieces, and fold a couple different shapes of boats, and see which one can hold the most weight before sinking. And now it's time to max it out.
But before we do, here's how you can fold your own tinfoil boat in less than 15 seconds. First, take a square piece of tinfoil, then fold it in half. Fold one corner down, and the other corner down. Then open it up and ta-da, you're done. If you want instructions on how to fold a more complicated boat, go to our website.
I have a feeling I'm gonna need a few extra lab coats for this experiment. Like I was saying, let's max out the tinfoil boat and find out a little bit more about why boats float.
which is not, I wasn't expecting to be in the pool just yet, but this is where we're gonna build our giant tinfoil boat, so why not? Who's Nia?
Phil, you're wet.
I thought I was gonna come in over there, but I came in on the water sled. I think I had the coordinates wrong. Anyway, this is Husnia, and she's from Let's Talk Science, which is all about science education, right?
Yes.
Just like us. So you're gonna help me max out the tinfoil boat. I think I dropped it in the water. Hold on. Whoa! Here, where? There it is. The tinfoil boat. The tinfoil boat.
Phil, this is a boat?
Well, it looked a lot better before I came down the water slide, but that's the idea, and then we make it bigger. What do you think?
I don't think it's gonna work, Phil.
Oh, well, why not?
Tinfoil is very thin,
Uh-huh.
and it might not hold the shape of the boat.
Well, I still think we should use tinfoil, though.
Why?
Well, because the small experiment was tinfoil, and I bought all of this tinfoil.
Then let's do it.
Tinfoil?
Tinfoil?
Okay, high five. I will, I'll take the tinfoil, and you take that, and I'm gonna have to dry off at some point.
Welcome to Shipbuilding for Pirates. I'm Swubby, and I've built some of the finest pirate ships for some of the finest pirates this side of the Caribbean. And I can teach you to do the same. But first, you need to know your basics. Mass and volume. Let's start with volume! But not that kind of volume. Which of these two chests do you think has more volume? Right, this one here. Which of these two balloons do you think has more volume? Right, this one here. Volume is how much space something takes up. Which of these two chests has more volume? That's right, they're the same. But which of these two chests has more mass? Which is heavier? Hard to tell, isn't it? But what if I told you that this one was empty and this one was full of treasure? Oh, loonies. Now, which one has more mass? That's right, this one. These two chests have the same volume, but this one has more mass. This chest has more volume than that one, but this one... My loonies! That chest does not have as much mass. Volume is how much space something takes up, and mass is how heavy something is. And when you look at them both together, you're looking at density. Join us next time on Shipbuilding for Pirates, and then we'll look at how volume, mass, and density work together to make something float. Oh, my precious, precious loonies. Are you all right, my pretties? They can't talk, so I'm not sure what they're saying.
So, Husnia and I get to work constructing a large tinfoil boat. Our first design is just sort of a square, folded together out of a very large sheet of tinfoil. Simple, but can I ride in it? There we go. A giant tinfoil boat, just my size. Woo-hoo-hoo-hoo.
I don't know if it's gonna work. It's too thin.
You think it's too thin?
I feel like yes.
Well, what should we do?
Do you want to test it?
Let's test it. Okay, good idea. So here's the most important question. Do you want to test it or should I test it?
No, you test it.
All right, here we go. Putting it in. First test, does it float on its own? Yeah! Floats on its own, no problem. If I just get in very carefully, then it will work fine. See, if I'm careful about how I get in, no, it's fine. See, if I just get in like that.
Oh my... Phil, are you okay?
Wait a minute. It's sort of, no, that's just air. You know what went wrong? It wasn't boat shaped. I think if we make it look more like a canoe, because canoes float, if we make it look like a canoe, it'll work great.
No, Phil. We need some support. If we add a couple of structures in between, then we add support to it.
I'll tell you what, let's make a boat like I want to make and a boat like you want to make, and we'll see whose is the best.
That's a good idea. Okay, let's do that.
All right, let's do it.
Welcome back to Shipbuilding for Pirates. I'm Swabby, and now we know what volume means, what mass means, and that together it can tell you something's density. Now let's find out why things float. Let's say we're out to sea and my treasure chest gets swept overboard. Oh no! But it's all right. It floats because it pushes enough water out of the way, displaces it to carry its mass. But what if my treasure chest had more treasure in it? Well, we're giving it more mass, but not more volume. Too much mass and not enough volume, and it will sink. Oh no, my loonies! You need more volume if you want to float more mass. And that is why things float. I'm Swabby, and thanks for joining me on Shipbuilding for Pirates.
So, the first version of the tinfoil boat didn't work out too well.
Like that.
But my idea is to build a tinfoil boat more like a canoe to see if a different shape makes any difference.
Tinfoil canoe!
Very Canadian.
Very Canadian. The canoe part, anyway. I don't know about the tinfoil part. So, Husni and I had a bit of a disagreement of why the last boat didn't work. I thought it was because it wasn't shaped enough like a boat, so this one looks like a canoe.
What I thought is that it requires some structure.
Structure so that it wouldn't fold together.
That's right.
And we'll see how it goes.
All right.
All right, here we go. Did it work?
No.
Okay, your idea next.
Mini Max.
Did you know it's easier to float in salt water, like in the ocean, than it is in fresh water, like a lake or a pool? That's because not all liquids are created equal. They have different densities. This is fresh water, or it doesn't have anything in it. And this is sugar. If I was to put 1 scoop of sugar in this water and stir it around until it dissolves, now this liquid is more dense than before I put the sugar in. Here's an experiment you can do at home using liquid density. This glass just has regular water with yellow food coloring in it. This glass, green food coloring and ½ a cup of sugar in it. This one has a full cup of sugar in it, and this one has 2 cups of sugar in it. Now, when you do this at home, you'll definitely want an adult to help you because you have to heat the water if you want to dissolve that much sugar in 1 glass of water. I'm gonna put them all in 1 container. You can do this at home, and when you do, I suggest you use a very small container because you have to be very careful when you put the layers in. You can use a turkey baster or a straw. When you put your finger on top, the air pressure will hold the liquid in and you can just drop it in. But these kind of take some time, so I'm going to use the syringe of science. I'm gonna use the most dense liquid first because that's the one that's gonna want to be on the bottom. I carefully put it on the bottom of the container. The next layer, be very careful. And you'll see that the red and the blue aren't mixing because they have different densities. The blue is heavier than the red. We'll add the green, and you can see even when it drips into the red, it comes back up to the top because the green liquid isn't as dense as the red liquid, and the denser liquids push the lighter liquid up. And now we're gonna add the yellow, which of course has no sugar in it at all. And there you go. All the layers stay separate. If you put it on a light, you can really see it. Liquid densities. Now, let's max it out. Ta-da! The longest length of liquid layers. 12 liquids all organized by density. Starting from the bottom, we have honey, corn syrup, chocolate syrup, maple syrup, dish soap, whole milk, water, dyed blue, vegetable oil, extra virgin olive oil, rubbing alcohol, baby oil, and lamp oil. Liquid density. I really want to mix it up, but it took me a long time to make this, so I'm not going to.
Our first 2 attempts at a tinfoil boat haven't gone so well. Husnia's idea is to make a tinfoil boat and add some more structure, because the tinfoil just wants to collapse when I get in it. So we start with a large piece of cardboard on the bottom, Then we wrap the tinfoil around it and shape it into a boat. After that, we add some supports across the top to stop it from folding in when we add my weight to it.
This boat feels a lot stronger than the one I was just in.
I told you.
So how does all of this work?
So we got some support using broomsticks and then some cardboard paper. And then underneath we have cardboard.
And so how will all of this help the boat not sink with me in it?
Right. The broomsticks will prevent it from folding this way and you won't sink.
Good.
The cardboard will prevent it from folding this way and you won't sink again.
Not sinking is my favorite thing to do in the tinfoil boat. All right, so let's try it.
Let's do
now,
it.
Are you gonna get in this one?
I'll tell you what, Phil. If you get in and you don't sink, I'll go after you.
Deal.
All right.
All right, here we go. It's sort of working. Oh no, water's coming in. It's sort of working.
It's almost working.
Uh-oh.
Wow.
No.
Hold on.
1, 2, 3, go.
Another thing I learned is that a very light tinfoil boat can be very heavy when it's full of water.
I don't know if fixing it is in the cards. I think we're gonna have to build another boat. So what do you think we should do?
Let's add more structure.
More structure.
Oh, yeah.
What if we add like a metal rod around the outside and maybe some more metal rods and ribs, and we wrap it all in tinfoil, and you think it'll work?
Let's give it a try.
Let's give it a try.
Don't worry about it. I got this.
No, I get it. I'll get it.
Sure.
Who wants to do an experiment with diapers? Oh! No, I'm serious. You may have a little brother or sister at home, which means you probably know where you can find some diapers. But there are 2 things you need to remember. First, ask an adult if you can use the diapers for your experiment. And 2, only use unused diapers, okay? Okay. So, you take the diaper, and if you cut it, be very careful, maybe get an adult to help you, over some black construction paper, like I have here, and you shake the diaper over the construction paper, you'll see that there's a little powder that comes out. And this is the secret ingredient. This is super absorbent gel. What it does is it soaks up all the liquid, and diapers are full of them. And you carefully pour it into a plastic cup, like that. Now you can see I have already done it with a number of diapers. It's important to use a plastic cup because it's a little messy, although it's non-toxic, it's totally safe, but it's still easier to clean up by just throwing the cup away. Now, add some water, and what happens is this super absorbent gel absorbs the water and turns very quickly into a paste. Look at that. Now, let's max it out. 5 kilograms of super absorbent gel, 500 liters of water. Now, it is time to do science! And I have my own stir stick. Yep, definitely coming along. I'm not exactly sure if we're getting anything on this camera, but I want to make sure it's recording. Yep, it's recording. There we go. It is definitely turning solid. Well, there you go. The giant super absorbent gel experiment. Corey, Trevor, I need some help getting out. How many outfits have I been through in this episode? How many outfits have I been through in this episode? Anybody have a towel?
There you go.
Thanks, buddy. That's great.
Husnia's idea of adding structure to the tinfoil boat was definitely right. We just needed to go further. So we did it again. This time, we made a much larger boat. We started with a sheet of cardboard, then wrapped the tinfoil around and added some metal supports taped to the cardboard across the boat this way to make ribs, as well as some other supporting pieces in the front and the back. Then another metal rod all the way around the top, and finally, supports across the middle. All right, feel how strong it is. I'm really excited about this version of the tinfoil boat. What we did is we used thwarts, big hard pieces of wood that we did last time, but this time we have ribs.
Ribs, right, which are made of a cardboard, a metal rod attached to it,
And shaped, and we did a whole bunch of them that go the whole length of the boat. And then we used all of this bendable metal, and we have one that runs all the way around the gunnels, and a whole bunch that run down the inside, and we even used bike fenders at the front and the back of the boat to give it super rigidity so that it hopefully won't go like all the other boats have done so far. Are you ready, Husnia?
let's do this.
1, 2, 3, lift. All right, let me get over. It floats, but that doesn't tell us anything because they've all floated at this point. It's only when I get into it. Okay, here we go. All right. Hey! Hey, it works! All right.
Oh, it's working.
Ha 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 ha! Look at that! It works perfectly. The tinfoil boat experiment has been done. Science Max, experiments at large. What do you think, Husnia?
The only reason I got into this boat because I knew it's gonna work.
Really?
Oh yeah.
So you knew you would never get wet. See, I don't think that's fair. I think it's time that you got wet. Yeah, I think we should go. I think you and I should just get wet right now. Just need
Someone help.
You're still dry, aren't you? That is so unfair. Science Max is a show where we take small experiments and do them big. If you want to try these experiments yourself, go to our website for instructions. But not all the experiments on Science Max are the kind you should try at home. This one, yes. This, no. Try this, don't try this. A big yes, a big no. I don't know how you could possibly do this one at home. And remember, if you're ever not sure, ask an adult. Thanks for watching Science Max Experiments at Large.
Science! I don't know what you're saying. I don't speak treasure chest.
The one thing I'm really trying not to think about is that this is the stuff that's in diapers.
Let me talk to your brother. Whoa, 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 whoa. Don't talk with your mouth full.